Hello and welcome to this episode of Math with Martinez. In today's video, we are going to go through this factoring guide, working through the steps that are required for factoring all these different types of polynomials. Our goal here today is to use this factoring in order to, as we will do on our next page, solve polynomial equations by factoring. So let's go ahead and get started going through this guide by looking at this first area where we are looking at a polynomial with just two terms. Now, what do we call a polynomial with just two terms, y'all? That is a binomial. So you'll notice here that we've got a little binomial here, right? We've got this a squared minus b squared. If something is in that form, it is called a difference because you're subtracting of squares. And when you factor a difference of squares, the result is always going to be the square root of your first term minus or plus. One of them will be plus, one will be minus, and then the square root of your second term. So let me show you all an example here. Let's highlight that so that we keep it visible. So let's look at an example here. Let's say that we had the binomial x squared minus 9. This is an example of a difference of squares because I am subtracting, that's that word difference, and then this is a square and 9 is a square. When we factor that down, what will that be? Well, it'll be two binomials, one adding the term, one subtracting the terms. And then we ask ourselves, what's the square root of x squared? It is just x. And what is the square root of 9? What is that, y'all? It is 3. So there you go. That would be one example. Let's look at another example. Say we had 16x to the fourth and then minus 25. This is, again, a difference of squares. Check it out. One will be plus, one will be minus because what is the square root of 16? It is 4. And what is the square root of x to the fourth? It is x squared. And last of all, what is the square root of 25? It is 5. And there we have it. Those are two examples of factoring a special kind of polynomial called a difference of squares. Another special binomial is a sum of cubes. That is when you have your first term is a cube, your second term is a cube, and like the word name here indicates, you are adding. When you have a sum of cubes and you're factoring them, the factored form will always look like so. The cube root of your first term plus the cube root of your second term, that's going to be in your first factor, and then your cube root of your first term squared minus the product of a and b, which are those cube roots, plus your cube root, not cubed, but just squared. So let's look at an example here. Make sure that we get this highlighted. All right, and an example. We could have the example x cubed plus 27. This is a sum of cubes because x cubed is a cubic term and 27 is a cubic term. I'm going to work to the side here so I have enough room. Here we go. Here's the setup. What is the cube root of x cubed? That is just x. And then what is the cube root of 27? I'm right here. I'm saying, what is the cube root of my first term? Just x. And now what is the cube root of 27? What number cubed is 27? And that is 3. Now we're just going to take that a and square it. And that goes right here. So a squared, that first term squared, is x squared. Then minus the product of those two terms, that's x and 3, so 3x. Then plus our second term, or our b term, squared, which is 3 squared. That gives us 9. There you have it. That is my sum of cubes factored. Let's do one more. Let's do 8x to the 6th power plus 1. This is a sum of cubes because what cubed is 8x to the 6th power? That's going to be 2x and, yep, squared. All right, and then what cubed is 1, or what's the cube root of 1? It is just 1. So there we go. Now let's make sure and take our first term and square it. So I take this 2 and square it, which is 4. And then I take my x squared and square it, which is x to the 4th. Then I subtract those two terms, the a and b, which is just going to be 2x squared. And then my last term, once again squared. 1 squared is 1. So there you have it, sum of cubes. The last special two-term, as in binomial, that we can look at factoring is a difference of cubes, and it's a lot like sum of cubes, except that we are subtracting. So that's going to look like a minus b as the first factor, a squared, but then it is plus ab plus b squared. Very similar format, and you won't have to memorize these formats. They are provided as one of your references when you're working, but you do have to use them correctly. So let's look at an example here of a difference of cubes. We could have 64 minus x cubed. This is a difference of cubes, where the first term, take the cube root of 64, that is just 4. Then the format is to subtract the cube root of x cubed, which is just x. Now take that first term and square it, that's 4 squared, which is 16. Now add the product of a and b, that's 4x. And then add your b and square that. So that's x squared. Very cool. All right, ladies and gents, now what about one more of these difference of cubes? Let's do this one. 27x cubed minus 8. What is the cube root of 27x cubed? That is 3x. And then the cube root of 8 is 2. Good. Then once you've got your a and your b, I like to call this my a and this one my b, then I can just look at my format and say, okay, well, in my trinomial here, I need to take my a and square it, so that's going to be a 9x squared. Now multiply them together. Oops. When I multiply them together, my a and my b, that's going to be a plus 6x. Make sure that you are adding in between. And then lastly, take that b value and square it. That's going to be plus 4. So those were all factoring when what you were given were just 2-term polynomials. Now let's look at factoring when you have 3 terms. What do you call a 3-term? It's called a trinomial. It's called a trinomial, and you could have trinomials when that leading term is either equal to 1 or greater than 1. So here is what we're looking at. We want to look and see how I like to summarize this is that it's going to, when factoring, we're going to look to see what multiplies to C and adds to B, because what we're looking at here is a trinomial of this form: a x squared plus bx plus c. So when I'm mentioning here that it multiplies to c and adds to b, we're looking at these numbers right here, because our a is in fact just a 1. An almighty 1. You won't see anything in front of that first term. Its leading coefficient is just a 1. Contrast that with this one. We're going to look at what will multiply. Multiplies to a times c and adds to b, because we will have something in front of our squared term this time around when our a is greater than 1. So look at that. You're going to have an a, a b, and a c value that you're going to be working with. But let's look here at this first one. We're just going to do one little example. Let's look at the trinomial x squared minus 6x plus 5. So what I like to do is use our cross and say, all right, what multiplies to c, multiplies goes on top, my c value is 5, and adds to b, which is a negative 6. So what's going to multiply to give me 5 but add to give me a negative 6? That's going to be a negative 1 and a negative 5. And those, ladies and gentlemen, finish my factors. I know that both my factors are going to have to start with x, because that's the only way if I use distribution, right? Because x times x is the only way to get x squared. But now I've got the rest of it. I know that the number portion of these binomials is a negative 1 and a negative 5. These are the easy ones, or the faster, but these, when a is something other than 1, are quite similar. Look at this example. Let's say that we had a 2x squared plus a 15x minus 77. Okay, we use the cross again, but we say what multiplies to give me a times c. This previous one, it was just c, but what multiplies to give me a times c? We are multiplying 2 and 77. 2 and 77, what is that? Ooh, let me grab my calculator real quick. 2 times 77 is 154. And then what adds to give us our b value, which is 15. Oops, I'm sorry, negative 154. So what will work there? What is going to be the factors of 154 that will add up to a positive 15? Well, y'all, it might take you a little while You may have to start listing them out here and kind of go through and say like, well, what about 2? What happens if I divide by 2? What happens there? 77. Would that ever work? Could those ever add up to 15? No. So you keep going, you keep going, you keep looking, cross off the ones that don't work, and then you're going to finally come to factors that will work, like 22 and 7. That'll work if you make that 7 negative, because 22 minus 7 is 15, and the product of those is negative 154. So now we use those two numbers to split the middle. And so I'm going to say plus 22x, and then minus 7x, and then have the first and last term just like it was. Then I group up right here, and I group up right here. And we ask ourselves, okay, what is the GCF in that first grouping? Looks like I can take out a 2x, leaving me with an x plus 11. And in the second group, a negative 7 for sure, and an x, and if I factor out a negative, it will be a plus 11. And cool beans, because look at what is inside. They match. One of our factors would be the x plus 11, and the other factor is from those GCFs. So that is trinomials. That is factoring trinomials, the two different types that you might see there. Now, what if you have a 4-term polynomial? Then the methodology that we're going to want to use here is grouping. So you're going to want to find a GCF of each part, and then factor the binomials. Maybe instead of part, I'll call it a pair, and then factor the binomials. So take, for example, if we have, let's say, x cubed minus 2x squared plus 6x, and then minus the 12. So what you want to try and do here is go ahead and group up like we did in that previous problem. Look at this group, look at this group. All right, once they're grouped up, I think it's a little easier here. Look at that first group. What is the GCF? What could you factor out of x cubed and negative 2x squared? It looks like just an x. And then what's going to stay inside is an x squared, and then minus a 2. Oh, my bad. I can factor out more than that. I can factor out an x squared, and then inside be left with a x minus 2. Whew, that was a close catch. And then from our second grouping, let's see what can I factor out of that second pair? It looks like I can factor out a positive 6. And then inside what is left, looks like just an x minus 2. Oh, look at there, look at there. It's just like when we were working with our trinomials. So then what we have is one factor, the x minus 2, and the other factor, the x squared plus 6. Now I cannot factor that anymore because it is x squared plus a 6. It is not to be confused with a difference of squares because it is adding. So there you guys have it. These are the approaches to factoring your polynomials in order to be successful in solving polynomial equations by factoring. So use this little guide as we work through these lessons to come. And that is it. So if you guys have any questions, please, please, please share those now. And until next time, stay fired up.